Hi everyone, I'm Matt Horton. I'm a data architect at a company called CDL. CDL, we're an insurtech based in the UK. We're a market leader in highly competitive retail insurance market, and we offer software solutions that cover policy admin, real-time pricing, quote manipulation, and of course data and analytics. I'm an AWS community builder, and I'm also one of the 50 global Qlik luminaries. It's really good to be here today in person to share CDL's use cases and best practices for deploying Qlik Replicate in the AWS cloud. So CDL's retail insurance solution is called Strata, and it's able to handle every aspect of our customers' core business. Strata supports insurance providers to bring products to market. We use a multi-channel strategy, and we do this, all the data is held in a single database. Components of the system enable the sale and administration of policies, including telematics-based insurance, and they're able to sell all these policies via the web, price comparison sites, contact center, mobile and voice devices. It's used by some of the UK's largest personal lines providers, and the system generates millions of transactions every day, and these are spread for a highly relational data model. So in order for us and our customers to have the ability to develop powerful analytics capability, we bring the Strata data into a less complex and more consistent data model. So our first use case for Qlik Replicate came from a need to cost optimize our Kingfisher business intelligence solution that we'd built for our very largest customers. The solution provided data feeds from the Strata policy administration system into customers' data warehouses and data lakes. The solution takes about 700 database tables, and all those have been optimized for online transaction processing. And then we denormalize the data into about 100 views that are optimized for the analytics workloads. To provide the solution, we were using a proprietary change data capture product from our database vendor at the time. The product worked well, but it was only available to customers who had an enterprise license for that database. So we're a software as a service provider, so we needed the ability to be able to offer the same functionality to all our customers. These range from startups, SMEs, all the way up to large global financial services companies. So to address the issue of cost optimization, to find that cost optimized solution, we looked at a number of change data capture tools that were available on the market, and we did proof of concepts and performance tests with them. And we decided to proceed with Qlik Replicate as our data integration partner. So it offered a vendor-neutral solution, yet supported a large number of source and target endpoints. The technical team at Qlik were really keen to work with us in partnership, and that was highlighted by their ability to take our feedback on board and actually inform their product roadmap. Also, our commercial team worked well with the Qlik account team, and they actually came up with a cost model that was in line with our budget. That model was brand new and created to support our very specific OEM use case. And for us, this just demonstrated a real desire to work together and solve problems as a team. When we deployed Qlik Replicate, we saw a number of benefits immediately. The cost reduction that we were looking for was realized. We saw a cost reduction in the region of 60%. We were able to provide the solution to new and existing customers, regardless of their size. And there was also less tooling for our data engineers to be aware of and support due to that flexibility that Qlik Replicate had, supporting multiple endpoints via a single interface. We actually went from supporting and running 3 different change data capture tools down to 1. So we take a look at the architecture of the solution. With CDC, transactions are read from the source online transaction processing database and they're sent via Qlik replicate into our data platform, which we run in AWS. And the transactions are applied to an Amazon RDS instance. So RDS provides a cost-efficient and resizable database capacity. It's got automatic time-consuming. It automates really time-consuming administration tasks such as hardware provisioning, database setup, patching, and backups. So what this meant for us, by using RDS, our DBAs had a lot more time to spend with the software engineers tuning the actual code that interacted with the database. So to get the analytics data model, I said we denormalize the transactions within that Amazon RDS instance, and we use materialized views to do this. So you can think of these essentially as a series of data marts, and they're focused around kind of business areas, business functions like policy, call center, accounts. And by turning those transactions into those data marts, we reduced the number of database tables that the analytics staff needed to be familiar with. So as I said before, we went down from 700 in the OLTP system down to 100 in the analytics space. The other thing we found was we were also able to keep the data model consistent by abstracting changes that happen in the source database. So for example, if we start to move columns about to improve the performance of the OLTP database, that previously had a downstream impact on BI and analytics, but now we can abstract those changes away from the analytics staff, and we can keep the data model consistent in the data marts. The materialized views, they're made available to support data analytics workloads. Most customers choose a visualization tool to work with the data in the first instance. So a bit more on materialized views. We use what we call fast refresh technology, and it can achieve a latency as low as about 1 minute from the original transaction taking place to that being seen in the data marts for analytics purposes. While we're doing all of this, we are actually migrating away from a commercial database engine to PostgreSQL. Now, PostgreSQL doesn't support natively the concept of a fast refresh materialized view, so we actually have to build that capability into for that particular database engine. And to do this, we worked with experts from a team in AWS called the Database Freedom Team to deliver that project. We've open sourced it, and we continue to maintain that project. Also, a pal of mine, Tony Mullen, he's written a guest blog for AWS all about this. It's well worth a read if you're in the business of running PostgreSQL databases. If you scan the QR code, you'll find links to both the GitHub repo and the blog post. I'll post them on Twitter and LinkedIn after the talk as well. Okay, to make our deployments faster and consistent, we apply infrastructure as code to our Qlik implementation in AWS. We use a tool called Terraform from HashiCorp, and we define all the infrastructure related to those, related to Qlik replicate, so the servers, security groups, firewall rules, DNS entries. We define all that in a template, and then that template is subject to version control in Git, just like any other code would be. So to deploy the infrastructure, we just actually need to execute a command, Terraform apply, and this gives us flexibility. If there's an issue with the deployment, we can simply roll back the template to the previous version using Git and apply it again, and go back to the previous known good state. So deploying Qlik in our AWS account, we need a few things. Of course, we need the source database. We need the Qlik replicate product itself. We use a management layer on the top of that called Qlik Enterprise Manager. Obviously, we also need the target database, AWS RDS in this case. And all these components have to communicate with each other, so we apply the appropriate AWS security groups. The other thing we needed was we needed to define the tasks in the Qlik replicate product that define the process of taking the transactions from source and applying them to a target. And to do this, we use the APIs that are available through the Qlik Enterprise Manager product, so that we can not only automate the infrastructure, but actually automate the deployment of all the Qlik replicate config. So this includes like registration of the Qlik replicate servers with the enterprise manager, and also the creation of the task definitions. So this is a demo. It's actually quite old now. I think it's recorded a couple of years ago. It's still quite relevant. So it's using Terraform to deploy all the components required to take that data from the existing source database. At the time, this was Oracle, but and then replicate that through Qlik replicate using change data capture. In this case, it's going to an AWS S3 bucket, but the process is the same. So Terraform is going to create all the EC2 instances, the servers in AWS required to run the Qlik replicate software. It'll then add the register those with the enterprise manager, add the source and target endpoint configurations, and then finally create the task that defines how you take the data from source and load it into S3 in this case. So no servers running in AWS at the moment. So we're going to run the Terraform apply. So this is now creating all the resources in AWS. You can see servers starting to be spun up. That was enterprise manager and one replicate server there. So we've got 2 servers running. This is obviously speeded up slightly, but it is still pretty quick. You can basically have all of this deployed probably within about 5 minutes in real time. So if we go into Enterprise Manager, what you'll see here is all the servers have all been registered, the tasks have been created, so we've got a customers table and in Oracle, and we're going to load that into S3 and capture all the changes. So we go into S3, there's a JSON file of all of that data been landed in S3. So really quick, simple way of getting data and moving it about using multiple kind of source and target endpoints there. So obviously automation is key for us. So deploying all this is infrastructure as code. You're obviously going to get benefits from it. Main ones for me, reduce risk. Automation removes that human element. I'm not my best running manual deployments late at night. I'm going to make mistakes at some point. Consistency, you're going to get the same thing every time. And also speed of deployment, as you saw even in the speeded up video, but in real time you do all that with about 5 minutes. But speed of deployment through multiple environments, so you can roll out those changes quickly through multiple environments for multiple customers, and you don't need to scale up your team to do that. So we talked about our use of the APIs there, our Enterprise Manager for registering the servers and the tasks, but in addition to using it for deployments, we're also using it to manage our Qlik replicate estate. So we really like that the REST API has been expanded over time, and we've been using this to gather all the metrics from the replicate servers and tasks, and we're feeding those into Elastic Stack. So this is one of the dashboards in Kibana. So here we're visualizing key Qlik replicate metrics that we've collected by those REST APIs. We can see things like the maximum latency by both task, current, and also over a period of time. We can also see kind of in the gauge there what the average overall latency is across the entire replicate estate, because we're running this for multiple customers. CPU, memory utilization, it's also shown by both the server and the task. And finally, we can see along the bottom if the state of each task is good or bad. So we didn't do all this ourselves, so it's always good to seek out partners to work with, like Qlik and AWS. So in addition to the good work of the data engineering teams, we do really seek opportunities to do that, and it's something I'd encourage people to do. And really just to kind of validate your architecture with those partners like Qlik and AWS. So give you some examples of how we did that. To support kind of a seamless integration between deployment of technologies like Qlik Replicate, AWS have established a service ready program, and this helps customers identify products that are already integrated with AWS services like the AWS RDS that we were using, so they can spend less time evaluating tools and more time using them to scale up their products. So we went through this RDS ready process. We've actually been through it twice now. We've achieved 2 RDS ready designations. We're actually launch partners alongside Qlik for Amazon RDS ready. Latest one we won just this year. So in order to kind of receive an Amazon RDS ready designation, we had to demonstrate that our Kingfisher BI product followed AWS architecture, security, reliability, best practices to integrate with that Amazon RDS product. And you have AWS partner solutions architects that actually come in and they review the solution, and they cover things like general integration requirements, database, network configuration, connection management, high availability, and also they look at performance testing results as well. If anybody's seen the AWS well-architected tool, it's quite a similar idea to that, but obviously the focus in this case was on RDS. And we got to consider and tune things like connection pool sizes, JDBC, ODBC parameters, connection timeouts, and also plan for database failover and recovery. We actually took the opportunity to force a database failover during performance tests and validate that what we were expected to happen actually did. So as an engineer who's done a fair share of on-call, this is actually a really good way to build confidence in the organization's capability to manage disaster recovery type scenarios, because they don't happen that often, so when they do, you want to know that they've been practiced. Again, there's a QR code there. If you scan that, I'll post it on Twitter or LinkedIn afterwards as well. There's an AWS blog post all about RDS Ready. If you're in AWS and you use RDS, it's well worth getting your products validated using that program. Okay, so by combining that Amazon RDS database, integrating with Qlik Replicate, and also data visualization tools, our Kingfisher product enables high volume business transactions to be modeled accurately and consistency in near real time. And we're providing high volume insurance retails with this powerful analytics capability and data marts that they can access in a visual way. A couple of examples that who have allowed us to talk about them in public, customers of ours. iGo4 Insurance and Comfort Insurance, they're using Kingfisher to produce automated and repeatable near real-time analytics and visualizations of their business activities, and they're driving business insight and improving decision making. So for Comfort, they had a lot of manual management of a lot of bespoke spreadsheets, so they basically used the Kingfisher product to remove all of that. And now they're able to, one of the things they've been able to do is deploy their people resources more efficiently and focus on income generating activities. iGo4 Insurance, they're benefiting from the ability to consume live business data in near real time. They do this into their data lake platform, and they deliver a lot of scheduled feeds of data to business partners, and this is really supporting them in their ability to share data across the business. So technology and data is kind of what I do as a data engineer, but for us and our customers to succeed, we need to make our products really easy to use and allow people who are not data engineers to get value from their data. So QuickSight Q is something that we've been working with during preview to extend out our existing data visualization functionality. It's machine learning powered capability that uses natural language processing to answer your business questions. Something we kind of think a lot about is how we can enable data to be put in the hands of the business users who have the questions. And seeing the results of some of these new features, it's really exciting as customers can literally just ask it a question and it gives you an answer. Okay, so like any product team, we're continually working to add new features and make improvements. And we find that Qlik Replicate has been really flexible in this regard to support our delivery of our product roadmaps. So we're looking at the kind of future architecture here of CDL Kingfisher in the AWS cloud. And we see Qlik Replicate continuing to feed this data platform that's based on best-of-breed AWS services like QuickSight that you've just seen. Whilst feeding data from many common sources using that change data capture processing into something like this model here, we can actually further reduce the cost of analytics workloads by decoupling the storage from the compute. Some examples of services you can use to do this. So object storage like AWS S3 provides really flexible and cost-efficient storage for data lakes. And it has native integration with many analytics tools and platforms. We're using AWS Glue a lot to provide a serverless data catalog and also ETL for Python and Spark-based workloads. With Amazon Athena, you can pay for queries. You only pay for the queries that you actually run. So you are charged based on the amount of data scanned for each query. And this can be optimized using compression and open data formats like Parquet. And all of this is wrapped with data governance. So AWS Lake Formation provides central access controls for data and enforces this at the table, column, and also soon it'll be able to do this at row level granularity. So as we kind of heard in the keynote this morning, it's really important for organizations to be able to handle data in motion and process this in real time. So I'm going to finish with an architecture pattern using Qlik Replicate to support this real-time use case. So this use case for Qlik Replicate is used to take the transactions from, again, relational database systems and push those into multiple destinations. And have I gone off? No. Multiple destinations providing hot, warm, and cold storage. So with a streaming platform like Kafka, we can have both near instantaneous reporting and also use modern event-driven architectures that respond to events on the stream. So here you see kind of loosely coupled software components. So AWS Lambda functions here. They're able to read those events that are coming in real time off those topics that they subscribe to, read those events from Kafka. And building systems like this around an event-driven architecture, it simplifies horizontal scalability for distributed computing models, and it makes them a lot more resilient to failure as well. So obviously this is all quite technical, so let's look at an example of how making data available via those the CDC, like Qlik Replicate tools, into event streams like Kafka can trigger and actually trigger positive interactions with consumers. So here we have Paul. Previously, he had a motoring conviction that's just expired. So that means we can process that event and give him a notification that his insurance premium can be reduced. We've also got information flying around as an event on the valuation of his vehicle. It's worth less than what he had it covered for. So if we reduce the level of cover, the insurance premium can be reduced as a result. And also we've got MOT data, so we can see that the consumer might not be doing as many miles as they used to, perhaps they work from home. So reducing the annual mileage, again, we can offer Paul a reduction in his premium. So obviously in the background here we had events triggered from those transactions. The code is executed only on the event happening. Trigger the notification to the consumer, and we got, hopefully, a positive interaction via the app. So I hope you can been able to see that the use of Qlik Replicate in our data architecture has been a really key part of bringing various data sources together and to be able to turn transactions into insights and trigger those positive interactions for our customers. Thanks very much for listening. Do we have time for Q&A? Got 5 minutes if anybody's got any Q&A.